Hello, this is your virtual content specialist for special education, here with the lesson for 8th grade for April 7th. This lesson, as with all lessons, can be found on TeachHub, and all lessons provide for teachers the title, the focus question, the learning objective, the standards, and the lesson objectives for each lesson. Additionally, we provide guidance for using this resource, including instructional and technology guidance, general lesson guidance, guidance for summarizing, guidance for assessment during instruction, and general methods for engaging with students with disabilities and multilingual learners. 8th graders will be working on the Exponents and Scientific Notation unit, Day 19, representing large numbers on the number line, Part A. How can large numbers be represented on a number line? The introduction is going to present students with a number line with the endpoints of 0 and 10 to the 7th power, and they're going to label the tick marks on the number line. Students are also going to explain how they decided what labels would be appropriate for this number line. So this warm-up is going to prompt students to reason about values on a number line that end in a power of 10. So it's going to enable them to visualize and make sense of numbers expressed as a product of a single digit and a power of 10, which prepares them to begin working with scientific notation. And so you're going to expect students' responses to either be incorrect or partially correct, and it's not important at this stage that all students understand the correct notation, so it's not necessary to extend the time for this reason. And students should be discussing with partners for social emotional functioning purposes, and during the partner discussions, identify and select students who have partially correct responses to share during the whole class discussion to push towards having a correct idea by the end of the lesson. And so again, this should be done in groups of at least 2. That way students can have peer tutors, and for additional support for students with learning disabilities, allowing them processing time, especially if they have processing errors. And so you want to check in with individual students as needed to assess for comprehension during each step of the activity. And so the possible responses should be as such: 0, 1 times 10 to the 6th power, 2 times 10 to the 6th power, 3 times 10 to the 6th power, 4 times 10 to the 6th power, 5 times 10 to the 6th power, 6 times 10 to the 6th power, 7 times 10 to the 6th power, 8 times 10 to the 6th power, and 9 times 10 to the 6th power. As indicated, some misconceptions can be that students are going to count the tick marks instead of the segments and think that 10 to the 7th is being divided into 9 or 11 parts, and you're going to ask these students to instead mark each segment with a highlighter to count them. Some students are going to try to label the tick marks as 10 to the 1st power, 10 to the 2nd, 10 to the 3rd, etc., and as a result, they may say that 10 to the 7th power is shown in the wrong place, and ask these students how many equal parts 10 to the 7th power is divided into, and how they would write that as a division problem or in a fractional value. Some students may label the tick marks as 10 to the 6th power, 20 to the 6th power, 30 to the 6th power, etc., and you want to ask these students to expand 20 to the 6th power and 10 to the 6th power into the repeated factors and compare them so that they can see that 20 to the 6th power is not twice as much as 10 to the 6th power. Some students may work with the idea of 1/2 and label that middle tick mark as 10 to the 3.5 power. And you want to explain that this tick mark would have a value of 1/2 times 10 to the 7th power, and ask these students to use what they know about powers of 10 to find the value of the first tick mark after 0. So after going into your small groups, your virtual small groups, or your virtual one-to-ones, you're going to ask selected students to explain how they labeled the number line, and you're going to record and display their responses for all to see. As students share, use their responses, correct or incorrect, to guide students to the idea that the first tick mark is 1 times 10 to the 6th power, and so on and so forth. That way it gives students the opportunity to connect the number line representation with the computational rules that they've developed in the previous lessons. So, again, if a student claims that the second tick mark is 20 to the 6th power, they can check whether 20 to the 6th power is equal to 2 times 10 to the 6th power by expanding both expressions. If by some chance it's not uncovered in the students' explanations, you might want to ask them the following questions to make sure that they can understand how to label the number line correctly. So how many equal parts is 10 to the 7th power being divided into? It's being divided into 10 parts. If the number at the end of this number were 20, how would we find the value of each tick mark? Divide 20 by 10. Can we use the same reasoning with 10 to the 7th power at the end? The answer is yes. What is 10 to the 7th power divided by 10? 10 to the 6th power. What does this number represent? The distance between the tick marks. Can we write 10 to the 6th power as 1 times 10 to the 6th power? The answer is yes. And if the first tick mark is 1 times 10 to the 6th power, what should the second tick mark be? It should be 2 times 10 to the 6th power. This portion of the Explore, in order to support students with disabilities, allow them to continue working with their peer tutor, and you want to eliminate barriers for any conceptual processing errors. So assist students in seeing the connections between the new problems and prior work. Students may benefit from a review of different representations to activate prior knowledge. And so they're going to be plotting the following points on the number line. And so this is how the numbers will be represented. Please note that 5 times 10 to the 8th power would not be able to be placed on this number line since 10 to the 7th power is our endpoint. In this portion of the Explore, students are going to solve this word problem, and they're going to estimate how many times larger the global population is than the U.S. population. And the answer is approximately 20 times larger. And students may reason it as 7 times 10 to the 9th power is roughly 20 times as large as 3 times 10 to the 8th, because 7 is roughly twice as large as 3, and 10 to the 9th is 10 times as large as 10 to the 8th. At the end of the lesson, students are going to summarize. You can support them with a sentence starter, and then they can begin working on the cool down. For additional practice, low-level students can work on Khan Academy, approximating with powers of 10, medium-level learners with Open Up Resources practice problems, and high-level students with Engage New York's Grade 8 Module 1 Lesson 8 problem set. As with all lessons on the Teach Hub, they come with resource citations, so you can look at the adapted materials to further support digital learning. If you have any questions, please reach out to your virtual content specialist. Thank you.